Okay, let's talk just a little bit about water. Water is interesting when it comes to acids and bases because it can kind of form both. It can be an acid in some cases, it can be a base in some cases. And to understand this, we have to think about the actual chemical definition of an acid and the chemical definition of a base. So in chemistry, an acid is anything that can give up a hydrogen ion, a proton. So when we look at a water molecule here, we see that there is one oxygen and two hydrogen atoms. Now when water molecules are kind of all mixed with each other, sometimes this water molecule can actually give up one of these hydrogen atoms. And that hydrogen atom can go off on its own and connect to something else. And what that leaves behind then is an OH, and it has a minus charge because of the way things work out as far as the charges go. But this hydrogen atom has now been donated. It can go and attach to another molecule, and that's the basis of an acid. An acid is anything that can give up an extra hydrogen. So for example, hydrochloric acid, HCl, is an acid because it has that hydrogen that it can give up. Well, water has that one hydrogen that can give up. It actually has two hydrogens, but this one, once it loses one, it's a lot harder to get rid of another one. But that hydrogen atom can actually go off and disconnect from the OH, the rest of the water molecule, and that's what makes water able to act as an acid in some cases. Now, it's only going to do that if it's mixed with something that can take on those extra hydrogen ions. So that hydrogen atom has to have a place to go. But in those cases, it can actually act as an acid. Now, a base is pretty much just the opposite. Let's put this stuff back here. A base is anything that can take on an extra hydrogen. Let's say we do put this hydrochloric acid into a solution with water molecules. This hydrogen over here of the hydrochloric acid is going to dissociate, so we'll be left with an H plus and a Cl minus. This H plus then is going to be looking for something to attach to, and so it can kind of come along and it can attach and form another bond with this water molecule, because this oxygen basically has extra space on the one side where it can form up, and so it'll form another bond between the water molecule. And now we have an oxygen with three hydrogens. So we actually write that as H3O. We have to have the positive charge up there still. In fact, we give this thing, this H3O molecule, a special name. We call it hydronium. But because this water molecule, the original water molecule, was able to accept a hydrogen, in this case it's acting like a base. A base is just anything that can take on that extra hydrogen. Now what's interesting is when we look at a mixture of water, there is a certain number of water molecules that are going to give up their hydrogen, and so they're acting like acids. So this one's going to give up its hydrogen, and it's going to be left with that negative charge. And then there's going to be a certain amount of water molecules that then can take on that hydrogen and form hydronium. So this water molecule over here is going to form that hydronium ion. So it's going to have a positive charge. So in any water mixture, the water that you drink straight out of the tap or distilled water, it doesn't matter, there's a few atoms that are acting as acids and giving up a hydrogen atom. There's a few molecules of water that are acting as bases, and they're taking on that extra hydrogen to form that H3O+. Now this is going to happen at a very low rate. There's going to be very few of the water molecules that actually do this, but we can see in this case both water molecules started out normal. One of them acted like a acid, one of them acted like a base. One of them gave up a hydrogen ion, the other one accepted it to form the conjugate base. And so water can act, depending on the situation, can act as either an acid or a base.